on this computer for a second. Yeah. So if people want me to go over Cheater's Hangman, I can do that. Again, I apologize for, suddenly doing this over Zoom. It is not my intention to do a class over Zoom every week for the past 3 weeks. Turns out kids are a lot of hard work. So oh, okay. And so otherwise, if you don't want to talk about this one, I can talk about the upcoming 3 assignments we have before right before the end of the semester. And I'll just briefly I talked about the sorting assignment yesterday. Okay, or not yesterday, but you know what I mean, last class. Data structures. Here you go. So with regards to that, the sorting assignment can be done in any programming language. Now, which ones are the important ones? E.g., which ones should you care about for the final exam? Because as much as I'd like to say all of them, that's not true. And I know that's not true. And the answer is that there's always 2 that we care about in academia. It's quicksort and merge sort. Those are the ones we care about in academia because those are recursive. But also, I really enjoy talking about, but it's not just what academia cares about. It's what the individual professor cares about. And I care about insertion sort. I care about it a lot. Why do I care about insertion sort a lot? Okay. And the reason is that insertion sort is very unique when it comes to other things. It's much less efficient on large lists, but it provides several advantages. For instance, you can do a 3-line or 5-line optimized C++ version. If it's extremely small, like we're talking less than 64 items, it's still worth using because you're not having that recursive overhead yet. And maybe even less than 32. But the point being, for short data sets, it's great. It's much more efficient, it says in practice. And the reason for this is that it kind of stops when an item gets into the right place. That's what it means it's adaptive. So essentially, if you've got something that's primarily almost sorted already, if you've got some sorting, if you've got a data set that's like only one item is out of place, then great. It's just going to take O of n time to sort that thing, whereas quick sort or merge sort will take a long time. So it is very, very efficient with regards to that. The other thing, though, that makes it really unique is that it is online. It can sort a list as it receives it. So if you take so if you get the first half of the list, you can sort that first half of the list while the other half of the list comes in later. In other words, so for instance, if you're doing a sorting algorithm and you sort your data set, and then whatever program you're working on comes back to you and says, oh, we weren't done yet. We have all this other data that needs to be sorted too. With the other sorting algorithms, it's essentially you're starting from the beginning. With insertion sort, it just doesn't care. This is part of the reason why we combine it with merge sort to do TIM sort. So it's very, very useful with that regard. And that's why I like it, because it has uses that are typical. The one other sorting algorithm I feel kind of obliged to mention is a weird one. So all the other sorting algorithms we talk about in this class are, actually, I do need to talk about this. All the other sorting algorithms in this class are what we call comparison sorts. E.g., we sort things by comparing numbers together, right? And then if one's smaller, we do one thing with it. If it's bigger, we do another thing with it. And you're like, well, that's how you sort things. You compare 2 numbers. Right. But there are sorts that don't rely off of comparing things to one another. And I'm not talking about topological sort. I'm talking about things like, where is it? Radix sort. Where are you? Here it is, distribution sorts. And I bring this one up because it is an old sorting algorithm. Old sorting algorithm. And the way this works is actually kind of unique. I'm only going to briefly mention it here because I'm not going to test you on it, but it's worth knowing. Look at that weird runtime, by the way. It's WN, where W is the key length. Think if we're sorting numbers, think of that in terms of number of bits. So the idea here is that we sort things by the least significant digit. We kind of, so for instance, we take in this item, we'll first sort things by least significant digit. Those curly braces in here are typically Qs that we put things in. Then we sort by the next most significant digit. So here we sorted all the numbers by zeros, by twos, by fives, and by sixes. And then we sort those numbers now by second place, by the tens place. So 02, 802, 02, 45, 66, 170, 75. And then finally by the leftmost digit. And the idea here is that we just keep going over these. If we do it from left to right each time, then when we go over the leftmost digit, we'll be able to get there. It's a pretty cool sorting algorithm, but it does not rely on you comparing anything to anything else. So I just want to kind of mention that's a paradigm that exists. Now, once you're done with that, there are two other, there's 1.5 other assignments, which is the graph setup and the password cracking. The graph setup is actually fairly straightforward. The idea is that for the graph data structure, I'm not going to make you code it from scratch, or I'm not, or do something similar. That's not a useful lesson anymore, I think. I mean, because we can just kind of talk, oh, it's use either a 2D array or use hash tables on the back end. So it doesn't really matter. Instead, what matters more is using a library, I think, and learning how to use a library. So for instance, how do you interact with jar files? This is an older version of Jung, but that's fine. It works just well. I think there's a newer version on GitHub. That's fine. It works just as well. But this is a graphing library that allows you to do graphs. I've got tutorials in the lectures about how to set this up in Eclipse, in IntelliJ, and in NetBeans if you use that. If instead you want to work in Python, okay, you don't use Jung. Instead, you use a different graphing library. That graphing library is instead Network X. This graphing library. I had a friend who contributed to this in grad school. So it's nice. It's got that little thing there, and they've had that for like 10 years. It's just such a nice little minimalistic thing. But the idea here is that it is useful for doing when it says networks, it means graphs. We can use it's very good at what it does. The documentation is pretty thorough on how to use it. So really this first assignment over here, the graph setup assignment, is really just asking, hey, did you get it working? Notice how short it is. Create a graph class to store nodes and edges, or download a graph class such as Jung. Use to implement breadth first search and depth first search. Follow the video from class if you need a reference. Basically, show me that it's working. Okay. One thing I do see a common issue is that people go, okay, and they're like, I don't want to use Jung or Network X or whatnot. So I'm going to go to, I want to go to Geeks for Geeks, and I'm going to grab the graph implementation they have there. Be warned, I've seen people come away with what they think is a graph, but is actually a tree because it only has a left node and right node. Graphs can have any number of connections to any other nodes. Trees are a very, very special type of graph. So be warned that if you're trying to use a version that's coming from Geeks for Geeks, that might not work out. If on the other hand, you want to try something that if you want to try something with Chat GPT in this one, I'd be very interested to see how that works out. So that's my permission to you if you want to try generating a graph class with Chat GPT and then coding it with Chat GPT for this assignment. This is the appropriate assignment to check that out with. I'd be very interested to see how that works out. Or GPT or GPT-4, I believe. Now, so if you want to try using AI assistant for coding this, you have my full permission for this one. Just be upfront with me about this one. Because again, this one is only worth 50 points. It's to make sure that you aren't going into the next assignment completely empty. That makes sense? So now with, but there's other ones there, and there's also locally run versions that you can get to. There's a lot of different things. The other one, the last one is password cracking. It is a problem from Project Euler. I think it's Project Euler 97. Not let's see. Was it 93? Not arithmetic expressions, but archives 2. No, 79, not 97, 79. It was I just had it flipped around. So this is the last one. And it is a graph problem dressed up as a security problem, where we basically want to try to get somebody's recreate somebody's password. We use a special type of graph here called directic acyclic graphs, which hold a very special place in my heart because I did a lot of work with them. But those kind of graphs are very useful. They're the kind of graphs that you use when you're doing like prerequisite requirements and stuff like that. When you're following, I need to take this class, and this class. Then this is what you use. All right. Lastly, I believe I did do what I said I would do on Monday, and I graded your group exams. So I believe I saw an email saying from somebody who took their exam later that they still need their exam graded. So please let me know about that. If you need me to grade your exam, and I will do so. Okay. But otherwise, I think the grades for the group exams were very strong. I haven't taken a look at the average for the overall exam, but I know that the group exam, at least that worked out pretty well for a lot of people. So, but if you have any objections to the way that the group exam was graded, please let me know. If you're not sure why you got the grade that you got because you didn't submit it, reach out to the person who did, or you can tell me in one of the breakout rooms. So regardless, this one is this one's a file reading one. It's much easier to do if you've got use a graph library rather than trying to do it from scratch. That's why. But yeah, once you're done with that, we're going to be done with the homeworks. The remainder of the semester, let's see, we've got, so next week will be as normal where we go over assignments and the stuff. And then I think the last week of class, possibly starting on either starting on the 24th or the 26th, I'll be going and doing final exam review stuff. Yeah, it's kind of insane. That's so close to the end of the semester. So for final exam review, what I do is I don't write a practice final for this class. It's much more fun to grab other people's final exams from other institutions and go over those exams. And we can see because that lets us see other kind of questions. I also do have a couple of questions that are from final exams that have gotten taken down. I don't have access to, but are really good ones. And I think they're all good. And I wouldn't do it unless I thought they were good. I wouldn't do it if they weren't good guides for doing the final exam, but we'll do plenty of review. Yeah, let me put that in my calendar. Okay. All right, stop share. Stop recording.